Hi guys, so we're going to go over the stuff about proportionality that you've learned so far. So constant of proportionality, direct proportion equation, and how to decide if a graph is proportional or not, and how to read a graph. So I'm going to go through this PowerPoint with you, and while you're doing it, you should have out a piece of paper, a pencil, and a calculator. So how I want you to work this is we're going to click on a question. I want you to then pause the video, try and answer the question, and then play the video to see the correct answer and how you should work it out. So here we go. First question says, is this proportional? If it is, what is the constant of proportionality and what is the direct proportion equation? So pause the video and answer it, and then play me when you're ready. All right, when you do this, remember to figure out if something is proportional or not. We have to find the unit rate or the unit rate. So remember, unit rate we do as K equals Y over X. So I take my Y and divide it by my X, because remember, fractions are always division problems. So I would take out my calculator, I would just say 2 divided by 3, and I find out that this is 0.6 repeating. Then I'm going to do it over here. 6 divided by 9. Oh, I get 0.6 repeating. Okay, I'm going to do it again here. 12 divided by 15. Oops. Oh, this time I get 0.8. So what is this proportional? My answer here would be no. No. And since I answered no here, I can't do the other two parts. I can't find a constant of proportionality and a direct proportion equation. They'd have to be the same all the way through. Okay? So let's try the next one. Erase this stuff first. All right, so let's try this again. Remember, it's Y divided by X. So is this proportional? Yes or no? If yes, answer the 2 questions below. All right, pause me and try it. All right, what you should have done is done 8 divided by 7. So 8 divided by 7 is a really long number. So I'm just going to start off by writing 1.14. I'll squeeze that one in there. Okay, and then we're going to try it again. So we have 24 divided by 21. And again, I get that same long decimal, 1.14. And it goes on. And then we're going to try it one more time. So I have 32 divided by 28. And I get it again. Okay, so is this proportional? I would say, yes, it is proportional. So now I can answer this. What is the constant of proportionality? So remember, my constant of proportionality, that's what we call our K. And when it's like this, where it's a decimal that goes on forever, we're just going to write it as a fraction. So my Y was 8, and my K, or my X is 7. So I would say 8 sevens, and I would just leave it like this. I would simplify it if I could, but I would just leave it like this in this case. And then what is the direct proportion equation? Remember, the direct proportion equation is Y equals KX. So now that we know what the K is, we could say for this one specifically, it's Y equals 8 sevenths X. And that's my direct proportion equation for this one. All right, let's try another one. So is this proportional? Let's see. Remember, Y divided by X. Pause me and see if it's proportional. All right, let's try it. So I have 9 divided by 4. That gives me 2.25. Okay, I'm going to try it again. So this time I have 45 divided by 20. Oh, again, I get 2.25. And let's try it one more time. 81 divided by 36. Y divided by X. And again, I get 2.25. So answering the question, is this proportional? I would say, yes, this is proportional. What is my constant of proportionality? That means my unit rate. That would be the 2 and 2500ths. And then if I were to write a direct proportion equation for this, I would say y equals kx. But I know k is 2 and 2500ths. So I'm going to fill that in for the k and put an x behind it. So no matter what I put in for x, I could put in 10. I would say 10 times 2 and 2500ths would give me my y. Or I could say x is 100. I would plug that in and it would give me my y. That's what the equation is telling you. All right, one more. Is this proportional? Pause it and check. All right, let's check it out. So here I have y divided by x. So I have 4 divided by 9. When I do this, I get 0.4 repeating. All right, now I have 6 and 27. So 6 divided by 27. Oh, that gives me 0.2 repeating. And as soon as I find out it's different, I really could stop, but I'm going to answer the last one. 10 divided by 45. That gives me 0.2 repeating. So 2 of them are the same, but one of them is different, which means no, this is not proportional. So I can't answer these other 2 questions because it's not a proportional relationship. All right, let's try the next thing that we've been working on. So this says, does this equation represent a direct proportion? Okay, so again, yes or no. And then if you say yes, if so, what is the constant of proportionality? What would the k be equal to? So here's where we would try and get the y all by itself. So it's kind of like solving an equation. We want the y all alone. So I would drop my line from the equal sign, and I would say -8 on both sides. And when I do that, I'm going to get y equals, and that's what we want. We want it all by itself. Now, I can't subtract 8 from the 4x because the 4 has an x with it and the 8 doesn't. So I'm just going to have to write it like this, 4x minus 8. Remember in the video that we learned yesterday, if there's any addition or subtraction at the end of my equation, then I would say, no, it's not proportional. That means next year when you graph, it's telling you that the line is going to cross through -8 on the y-axis. We want it to be 0, so we don't want anything there at the end. So this does not represent a proportional relationship. Let's try the next one. Okay, does this equation represent a direct proportion? Let's try again. So pause me and answer it. All right, let's do this one together. So again, I want the y by itself, so I'm going to drop my line. The 5 is with the y right now, so I'm going to divide by 5. And I end up with y equals x over 5. And that's right. I would say that is proportional. There's no extra addition or subtraction at the end. So that is a proportional relationship. So what's my k? So that part's kind of tricky. When you have it written like this, your k is actually a fraction. This is saying 1x over 5. So I would say here that my k is equal to 1/5. Okay, let's look at the next problem. Is this proportional? So for the next few, we're going to be looking at the graphs and just saying, yes, it's proportional, or no, it's not. And then if it is proportional, tell me what the constant of proportionality is. And if not, then say why it's not proportional. So pause and decide. All right, let's look. So remember, there's 2 things that you must have for a graph to be proportional. One is that it goes through the origin, or 0, 0, so right here, which it does. And the other is that it's a straight line. And it can be a straight line diagonally like this, or it could be diagonally like this, as long as it goes through the 0, of course. Okay, so in this case, I would say, yes, it's proportional. Okay, what's the constant of proportionality? So I'm going to go, remember, constant of proportionality is a fancy term for unit rate. So I'm going to go to one unit, and I'm going to go up until it crosses my line. And then I'm going to go across over here. And I got to figure out what this number is right here. So I'm going to look at what my graph is counting up by. And it goes 0 and 100. And this falls right in between. So I know that question mark is 50. So I would say the constant of proportionality is K equals 50. All right, let's try another one. Here we go. Is this proportional? Pause me and figure it out. All right, well, in this one, remember two things, straight line. My line is definitely straight. And then two, it has to go through the origin. Here's my origin, and my line does not go through it. So I would say, no, this is not proportional. And if no, why? Well, I just said why. It doesn't go through the origin would be the answer. All right, let's look at the next one. Here's another graph. Is it proportional? If so, give me the constant of proportionality. If no, why not? Pause and answer. All right, let's look. Does it go through the origin? Yep, here it is going through the origin, 0, 0. 2, does it create a straight line? Yep, it's a straight line going up. So I would say, yes, this is proportional. So I'm going to put a Y up here. If so, what is the constant of proportionality? Remember, that's my K equals. So looking at this graph, I would follow the 1 up until it crosses my line that's graphed, and then I'm going to go over to the y-axis. So that means I got to figure out what this is worth right here. So I'm going to look at my graph and see what it's counting up by. See, it's counting up by tens, and I land right in between 0 and 10, which means that would be 5. So I would say my K is equal to 5. My constant of proportionality is 5. Just a couple more. Clara works as a hotel maid. The number of hotel rooms she cleans is directly proportional to the number of hours she works. So a couple things that you should pay attention to when you're looking at the graph. Okay, lots of times when we use the direct proportion equation, we say y equals kx. But sometimes they use different variables. Like here, they used t to represent time on the x-axis. And here they used r to represent the number of rooms on the y-axis. So when I go to write my equation, I'm not actually going to use x's and y's. I'm going to use t's and r's. I just got to remember that instead of a y, I'm going to put an r because it's on the y-axis. And instead of the x, I'm going to put a t because it's on the x-axis. So let's answer some of these questions. So question 1. Pause and see if you can figure it out. All right, let's try it. So if I'm looking here, what is the constant of proportionality? Okay, remember, that's a fancy term for unit rate. So I'm going to go to 1 unit. I'm going to go up to where it crosses, and then I'm going to go over. And I'm going to figure out what that value is. So I see it's counting up by 5s, and this falls right in the middle. So that would be 2.5 or 2.5. So I'm going to say the constant of proportionality, K, equals 2.5. Now this is where it can be a little tricky with the direct proportion equation. Like I was saying before, normally we say y equals kx, but we're not using y's and x's in this case. Instead, we're using t's and r's. So I just got to put it in the right spot. So instead of my y, here's my y-axis. I see that it's the variable r. I'm not sure why it's capitalized. Usually we don't do that, but since it is here, I will write it here too. So I would say R equals, and then my K, my constant of proportionality, in this case it's 2.5, and then my x-axis. But if I look at my x-axis, it actually doesn't use the variable x, it uses the variable t. So I'm going to put t here. So my direct proportion equation is R equals 2.5 t. One more slide. What does 6:15 mean on this graph? And if Clara cleans 10 rooms, how many hours must she have worked? Pause and try to answer. All right, let's look. So when looking at this graph, I'm talking about 6:15. 6 refers to the x-axis, or in this case, the t, and the 15 refers to the y-axis, or in this case, the one they have labeled r. So I use my labels at the bottom to help me. That 6 is referring to time, and it says h behind it because it means hours. So what does the 6:15 mean? It means 6, or in 6 hours. Actually, I'm going to do it like this. Oh, I can't write it out. I'm just going to say it verbally because it's going to take me forever to write it. It would say in 6 hours. And then I would look at what the 15 means. And the 15, if I'm looking at the y-axis right here, it says number of rooms. So I would say in 6 hours, Clara can clean 15 rooms. That's what the 6:15 means specifically for this graph. So you use your labels to help you when you're trying to tell what a coordinate pair means. Okay, and then let's look at the other one. If Clara cleaned 10 rooms, how many hours must she have worked? So I can use my graph here, and I'm gonna say, okay, 10 hours. I know that she worked, I know she cleaned 10 rooms. So here's 10 rooms. Here's the rooms on this side, on the y-axis, and here's the 10. So I'm gonna follow it over until it crosses my line. And there's where it crosses, and now I'm going to go down to figure out the time. I see it's 4 hours, so I know that Clara must have worked 4 hours to clean those 10 rooms. Now that you're done, I don't want you to turn in this paper. I just want you to keep it in your binder. But now you're going to work on a cut and paste activity. The cut and paste activity, I hope you will get done before the end of class. If not, you need to finish it up as homework tonight. Take a picture and submit it on Schoology for me. That's it, and I'll see you on Tuesday. Bye, guys.